Morning to 11th class student. In last video we have discussed the general introduction of alkali metal, where we study about the physical like atomic radius, ionic radius, and why ionic radius of alkali metal is smaller than that of uh, alkali metal ion is smaller than that of alkali metal. What is its ionization energy, hydration energy? So today we are going to study about their physical properties. All alkali metals are silvery white, soft, and they are light metal. Alkali metals are silvery white. First of all, their color is silvery white and they are light metal because of large size. Because alkali metals have large size, so they are silvery white and they are soft. And these elements have low density, which increase down the group from lithium to cesium. I hope it is clear to all of you that density is equal to mass upon size. That is also called mass upon volume. So as we move down the group, size increase, mass also increase, but comparatively mass increase in mass is more than that of increase in size. That's why their density increase as we move down the group. So all alkali metals are soft and light because they have big size. Because we already know that in periodic table alkali metals are present on left hand side. आपको पता है alkali metals left hand side पर होते हैं और फर्स्ट ग्रुप है. एज वी मूव फ्रॉम फर्स्ट ग्रुप टू 18 ग्रुप इन पीरियड, द साइज विल डिक्रीज. सो alkali metals have maximum size, so they are soft. Whereas potassium is lighter than sodium, the melting point of alkali metals are low, indicate the weak metallic bond. Now here one question is this one, that why alkali metals have low melting and boiling point. Melting and boiling point depends upon force of traction that is present in alkali metals, and metals have metallic bond, and metallic bond depends upon two characters. Number one is size and number two is valence electron. All alkali metals have single valence electron, but their size is big, so they show weak metallic bond due to presence of less number of valence electron and due to their big size. Because metallic bond is stronger when size is smaller and number of valence electron is high. So that the melting point of alkali metals are low indicate the weak metallic bond. This is due to presence of single valence electron and big size. The alkali metals and their salt important characteristic to an oxidizing flame. This is because heat from the flame excites the outermost shell orbital electron to higher energy level. When the excited electrons come back to ground state, they release radiations in the form, or they release energy in the form of radiation that falls in visible region. That's why they give color. Now the question is asked in this manner, that why alkali metals give characteristic color to flame. See here, that is given on your screen, that lithium has crimson red color, sodium has yellow, potassium violet, rubidium red, and cesium has blue. Why they show these colors when we put these alkali metal salt on the flame? You can do experiment at home. When you put some salt, that is table salt, on gas flame, then you find some yellow color flame is released. That is due to sodium element. Now question arises, why they give color. Sodium, its electronic configuration is 281. जो दैट आउटर मोस्ट शेल में जो थर्ड इलेक्ट्रॉन है, जब उसको आप फ्लेम पर रखते हो, वो एनर्जी लेकर एक्साइटेड स्टेट में चला जाता है. एक्साइटेड स्टेट का मतलब है फोर्थ शेल, फिफ्थ शेल, सिक्स शेल. और आपको पता है कि जो ये शेल्स होते हैं, एक्साइटेड स्टेट होती है, ये अनस्टेबल होती है. और अनस्टेबल होने का मतलब है वो अगेन एनर्जी लूज करके दोबारा से ग्राउंड स्टेट में आएगा. ग्राउंड स्टेट मतलब पुरानी स्टेट में आएगा. जो वो एनर्जी रिलीज करता है, दैट इज इन द फॉर्म ऑफ रेडिएशंस. और रेडिएशंस have particular wavelength and that's why they give particular color. So alkali metals gave color to the flame. और इस कलर से ही आप एल्कली मेटल्स को डिटेक्ट कर सकते हो, विच एल्कली मेटल इज प्रेजेंट इन द सॉल्ट. So this is your question, that here in this paragraph 2 3 questions are formed. First question is, why alkali metals are soft? Due to their big size, due to their weak metallic bond. Why they have low melting and boiling point? This is again due to their weak metallic bond, and metallic bond depends upon what factor? It depends upon size and valence electron. And next question is, why is potassium chloride gave violet color to the flame? This is due to excitation of electron from ground state to excited state. That's why they give color to the flame. This is your this paragraph questions. Now comes on this table. See, in this table you see that at atomic number is given. Atomic number means atomic number, that is equal to number of proton, number of electrons. Then atomic mass is given, it is given. Electronic configuration is given. See, in electronic configuration you see, you find that when you move lithium to sodium, potassium, rubidium, cesium, francium, the number of electron in outermost shell remains same, but the shell number change from 2 to 3 4 5 6 and 7. Ionization energy, as we move lithium to sodium, potassium, rubidium, cesium and francium down the group, in the group, first group, when we move lithium to cesium, then size will increase. See here, when the size increase, then ionization enthalpy will decrease. See, this line show that your ionization enthalpy continuously decrease, that is due to increase in size. So when you move up to downward, then size increase, and that's why ionization energy will decrease. Next question is hydration enthalpy. Hydration enthalpy, it is the amount of energy released when ion combine with required number of water molecule and form hydrated ion. Hydration energy depends upon size. Smaller the size, greater will be the hydration energy. So lithium has smaller size, so its hydration energy is maximum, that is 506 kilojoule per mole. But as we move down the group, the size increase, the hydration enthalpy will decrease. Next is metallic radius. Metallic radius is depends upon size. So when we move up to downward, then size increase, metallic radius also increase, ionic radius also increase. Melting point and boiling point depends upon what? Melting point and boiling point depends upon the size. Smaller the size, greater will be the melting point and boiling point, because when the size is smaller, then force of attraction, that is the strength of metallic bond, is high, because metallic bond depends upon small size of ion, that is smaller the size of ion, stronger will be the metallic bond. Second, it depends upon valence electron. Valence electron in all alkali metals remains same, but as we move lithium to cesium, then size increase, so metallic bond become weak, so force of attraction decrease, that's why their melting point and boiling point also decrease. I hope it is clear to all of you that when in melting point, when we move down the group, then melting point continuously decreases. What is density? Density is equal to mass upon volume, but as we move down the group, then mass, atomic mass is that is given on the second row, that atomic mass increase, that's why their density also increase. So this is all about your properties which you have already discussed regarding alkali metal. Now comes to next property, that is chemical properties of alkali metal. That is first chemical property is reactivity toward air. All alkali metals are highly reactive. Why they are highly reactive? First of all, question is, why alkali metals are highly reactive? तो इसका रीजन लिखोगे, ड्यू टू their big size, because they are present on left side of the periodic table, that's why they have big size. Second one, when the size is big, then their ionization energy is low, so they required low ionization enthalpy to remove the electron from their outermost shell. That's why their you can say, that's why their reactivity is high, and reactivity increase as we move down the group. Why reactivity increase as we move down the group? Because size increase, ionization enthalpy will decrease. That's why they can easily react. So here, chemical reactivity. In the starting of chemical reactivity, we have two questions, that why alkali metals are highly reactive due to their big size, low ionization enthalpy. And now the second question is, why alkali metals reactivity increase as we move down the group? The reason is again because as we move down the group, size increase, ionization enthalpy will decrease. That's why their reactivity increases. First is the reactivity toward air. They react with air and form oxides, because in air, the air is a mixture of gases. In air, carbon dioxide, nitrogen, oxygen gas, and some other gases are present. Out of these, oxygen is highly reactive, so it react with alkali metal and give oxides. So the alkali metal react with air to form oxides. Why alkali metal tarnish in air? अगर alkali metals को आप air में खुला छोड़ दो, they get spoiled or they get tarnished. Why they get tarnished? Because they react with air to form oxides, which in turn react with moisture. Moisture is also present in air and they form hydroxide. That's why they get tarnished. Lithium form only monoxide. Now this is very important question, that the alkali metal react with air to form oxides, and the reactivity toward oxygen increase as we move down the group. Listen very carefully. Reactivity toward oxygen further increase as we move down the group. See, first element is lithium. Lithium react with air to form simple lithium oxide. Lithium valency is 1, oxygen valency is 2. Lithium plus O2 is equal to Li2O, that is called lithium oxide. But now, when we move lithium to sodium, sodium has tendency to form peroxide. See, sodium react with air and form sodium peroxide. And other elements, sodium के बाद क्या आता है? Potassium, rubidium and cesium, they react with oxygen and form superoxide. Means lithium forms simple oxide, sodium form peroxide, and potassium, rubidium and cesium form superoxide. It means reactivity toward oxygen increase as we move down the group. Why? See here two lithium combined with react with one oxygen. Two lithium combined with one oxygen. Here two sodium combined with two oxygen. Here potassium, one potassium and one potassium, rubidium and cesium combined with two oxygen. It means reactivity toward oxygen increase, means tendency to react with more and more oxygen increase as we move down the group. This is because as we move down the group, the size of alkali metal increase. That's why their they can stabilize. So size of cation will increase. That's why big size cation can stabilize big size anion, because here oxygen increase. That's why it form big oxide, big size oxide, big size superoxide. So big size cation, as we move down the group, cation size increase, so big size cation can stabilize big size anion. Lithium is the only element that can also react with nitrogen gas to form lithium nitride. So lithium show exceptional behavior. Here lithium react with nitrogen to form lithium nitride, but other do not react with or other elements, other alkali metals do not react with nitrogen. Now question arises, why alkali metals are kept in kerosene oil? Because they have big size, they have small ionization energy, and they are highly reactive. They easily react with air to form oxides and then react with moisture to form hydroxide. That's why to protect their reactivity, to stop their reactivity, they kept in kerosene oil. Now next question is, what is the oxidation state of potassium in potassium superoxide? Here oxidation state of potassium in superoxide is +1, because O2 has -1 charge, and so it carry +1 ऑक्सीडेशन स्टेट. भाई आप बोलने क्यों